The Sun is entering the most intense phase of its cycle, which means it can cause severe problems on the Earth in the coming few years. These include electrical blackouts, power outages, and disturbances in the communications satellites for months. Most of you might not know the solar cycle and how it affects the space weather, so watch the video until the end. From Earth, the Sun appears to be a calm orb of light traveling across the sky. But up close, the Sun is the most dynamic place in the entire solar system. The Sun is a giant magnet, but it's not that simple. Every 11 years, the Sun's magnetic field flips. The North becomes the South, and the South the North. Another 11 years, the poles flip back again. This 11-year cycle is widely known as the solar cycle. As the poles flip, the Sun goes through a period of maximum and minimum activity. In 2020, the Sun was at a solar minimum when it entered its 25th cycle. Hence, as the Sun is waking up from its slumber, it's going to get stormy. Here, the storms are not the thunderstorms that you experience on Earth, but the powerful solar storms that have the strength to make our lives go haywire. The Sun will witness an enhanced activity in the coming years until July 2025, which means that the solar storms will be at their peak. But what are these solar storms that are causing us to worry about our internet connection? Also known as coronal mass ejection, or CME. A solar storm is a powerful ejection of charged particles from the Sun. These particles can travel several million kilometers per hour and take about 13 hours to 5 days to reach the Earth. Although Earth's atmosphere protects us from these particles, they can overwhelm the Earth's atmosphere if they occur in sufficiently large quantities. The charged particles of the solar storm can produce their magnetic fields. Eventually, they can interact with the Earth's magnetic field, introducing strong electric currents on the surface. This results in modifying the Earth's magnetic field and ultimately affects compass readings and other artificial structures, including the communication channels. But how do we know that solar storms can pose a threat to our communication channels? Do we have any proof of this? Have we seen anything like this earlier? Well, sadly, the answer is yes. The most severe solar storm, known as the Carrington event that occurred in 1859, reached Earth in about 17 hours. It caused the compasses to go haywire globally, terribly affected the telegraph network, and many operators even experienced electric shocks. Moreover, the aurora borealis, or northern lights, a pride of polar regions, were seen in Colombia, which falls near the equator. In 1921, again, a solar storm impacted New York telegraph and railroad systems. By now you might be thinking, if the Sun follows this pattern every 11 years, and we've seen such incidents before, then why do we need to worry this time? Well, there's a precise difference between what happened earlier and what could happen in the future. In earlier days, we had limited technology and limited communication channels. They did not entirely drive our life. However, our dependency on technology has skyrocketed in the past decade, and that's why the upcoming cycle is crucial for us. So, very little is known whether our current infrastructure can withstand a powerful solar storm or not. On top of all the speculations, a 2013 report stated that if a solar storm similar to the 1859 one hit the US today, it would leave 20 to 40 million people without power for 1 to 2 years. And the total economic cost will be $0.6 to $2.6 trillion. This is something that makes us worry. As per the new study, the possibility that a massive solar storm would occur within the next decade is 1.6 to 12%. And if such a solar storm hits the Earth, it will have sufficient strength to cause catastrophic disruption. It would cause significant damage to the planet's internet infrastructure and impact power grids throughout the world. However, it would cause severe damage to repeaters used for strengthening signals in long-distance fiber optic cables. At present, we have some understanding of how these storms would impact power systems on land. However, it's even more challenging to predict their impact on undersea cables connecting continents. The internet connectivity has been designed so that if one pathway fails, it can reroute the network, but at the cost of speed. Still, experts feel that most grids could go offline with a massive outage, limiting the internet to create the necessary link. Do you think the world can survive a global internet failure? Let us know your thoughts in the comments section. If you're interested in studying astrophysics at home, make sure to check out our Basics of Astrophysics series, the link to which is given in the description. This series explains everything at the most fundamental level, from the EM spectrum to telescopes, and from the birth of stars to the formation of black holes and galaxies.